Eric Burgess here, and we have been asked to find the equation of the line in slope-intercept form, and that form is actually given to us. If you don't remember, it's y equals mx plus b, where m is the slope and b is the shift factor that passes through the points 5, 2 and 2, 7. So these are pairs of x and y, and here we have another x and y. And so using these, we can get the slope. So our general strategy is 1, get slope. So we want the slope, find it. That's what we say. Get the slope, find the slope. And then 2, use a point to get the b. That's our plan, right? So let's move this calculator out of the way for now. We don't need to be too worried about that. So to do this, we got to remember the formula for slope. Now remember, slope is rise over run. That's what a slope is. And so when we write that in terms of points, that's going to be y2 minus y1 over x2 minus x1. Now it's just important that whatever point you pick to be x1 and x2 and y1 and y2, whatever points you pick, you're consistent. So here, I'm going to make this x1 and y1 and x2 and y2. But you could very easily swap these and make this one x1, y1, and this one x2, y2, just as long as you're consistent. So to get our slope, we simply plug this in. So y2, according to what we picked, is 7 minus, and then y1 is 2. And this is going to go over. x2 is 2, and x1 is 5, so we do minus 5. This is going to be our rise over run. So 7 minus 2, that's just 5. And 2 minus 5, that's negative 3. And so this is going to be our slope. So once we have our slope, we can plug that in. So this is m. That's what we call the slope. That's the variable we give it. So now using our formula, we now know that y is equal to mx plus b. So m is negative 5 over 3. So this is negative 5 over 3, and then x plus b. So if we can get this down to one thing that we don't know, we can solve for that thing. And here, we've been given 2 points, and we're told that these points satisfy this equation. They're both on the same line. So we can use either one to plug in for a y and an x. And so I'm going to go ahead and pick the first set, 5, 2. So our y is 2, so I put that where the y is at. And we do minus 5 over 3, because that's our slope. Our x, and now remember, when a variable is next to a constant, that's the same thing as multiplying those things. So I'm going to put it in parentheses. It's good practice. So our x is 5, so we put down 5 plus b. So now all we're missing is the b, and we can solve for that. So if we go ahead and plug this in, so we say this is 2 is equal to 5 times 5 is negative 25 over 3 plus b. And now if we add this quantity to both sides, we're going to get rid of this negative bit, right? Because that's how you undo negative things. You add them. And we add it to both sides because we have this equal sign. So we have to do it to both sides to be equal. So we say, okay, we're going to add 25 over 3 to both sides. Add 25 over 3. Doing this makes it so that these two, the minus and the positive, when they add together, they become 0. And we're left with just b on one side. So this is b is equal to 25 over 3 plus 2. Now, we can do this by hand, or you could do it using the calculator. I'm going to do it using the calculator, and I'll then do it using just by hand. So in the calculator, you can actually type fractions. It's really handy. So if we just turn this on, and this F1 menu allows you to type fractions. So I'm going to hit the green key and then F1. I'm going to go to the first option for fractions, and I'm going to type 25 over 3, and then I'm going to just put plus 2. And we're going to get 31 over 3. So this is an improper form, and we don't like to write things in improper form usually. And if you actually go to this function 1 menu again, so this green F1, so we hit green key F1, there is an option for U and D. I forgot what the U stands for, but this will put it in a proper form for us. So if we go ahead and, or in fact 3 will do it as well. So let's go to 3. So 3 will take something that was of this form, n over d, and turn it into a proper fraction. So we're going to take that. Answer is going to take it from here to here. We click it and we get 10 and 1/3. So we say b is equal to 10 and 1/3. All right, now if we were to do this by hand, let's go ahead, let's do this over here. We have 25 over 3 plus 2. So the rule when we're adding is we have to have the same denominator. So we need the 2. It's really 2 over 1. That's what we're saying, because right, 2 divided by 1 is just 2. So it's like we're writing the number 2. We're just writing it as a division. And then we say, okay, we need the same denominator, so we multiply by 3 to both the top and the bottom. And the reason we can do this is because 3 over 3, that's the same thing as 1. So when we multiply something by 1, that doesn't change. It stays the same. And so this is kind of like we're multiplying by 1. 3 over 3 is kind of like multiplying by 1. And we are going to get 25 over 3 plus, and then 1 times 3 is 3, and 2 times 3 is 6. And look at this. If we do this division, 6 divided by 3 is 2. So we still haven't changed it. It's still, this is still 2. We've just written it in a way that works better for what we want. And then when we add these, when we add fractions, the denominators must match, but you don't add the denominators. It just stays the same. And then we do 25 plus 6, which is 31, which is the exact thing that we got right here. So there's the way of doing it by hand. And if we wanted to reduce, you would simply divide. So the bottom number divides into the top number. So it's going to be 3 into 31. And if we look at this, 3 goes into 3 once. We get 3 down here. That's 0. Bring the 1 down. 3 cannot go into the 1, and so it goes in 0 times. It can't go into it at all. And then normally we would add a decimal, and you would keep going if you wanted to get a decimal answer. But in this case, we say we have a remainder of 1, and so we put that remainder over the top, and our denominator doesn't change. So we would get 10 and 1/3 that way as well. So all we need to do now is plug that in. So our original form was y equals negative 5/3 x plus b, and we were just missing the b, right? Because y and x, those are points on the line. And so we don't plug those in unless we're solving for something. So we say, okay, that's y equals negative 5/3 x, and then b is positive 10 and 1/3. So this is our equation. This is what you would write. You would say this is the line that contains those 2 points. And you can even check it. So this would be our formula, and we can actually also check it. So what this is saying is these 2 points are on this line, right? That's how we got this line. We found their slope, and then we're going to use that to find other points on this line just by picking an x, and we get a y. So if we put in an x of 5, we expect a y of 2. If we don't get that, then this equation is wrong. It doesn't contain these points. So this is a way to check it. And we can also plug in an x of 2, and we should get a 7. So we used these points to make this equation. So let's check this other one real quick, because sometimes you can't check every single thing on your problem. And so let's check this other one. If this one checks out, you can be reasonably confident and move on to the next question. So if we put a 2 in, we expect y to be 7. So let's plug this in. So we have negative, and then let's clear this. We want negative. There's the negative key. And we want to type a fraction. So I'm going to put the F1 menu, so the green key F1. Or you could just type 5 divided by 3 in parentheses. Negative 5 over 3. And then our x, remember we're multiplying these. Our x we're going to pick as 2, because that's what the point has. And we expect to get a 7 when we're done with this. And then we want plus 10 and 1/3. So we put plus 10. And to type on the calculator here, 10 and 1/3, again, we're just going to type a fraction. But the calculator gets a little confused when we type like this. So you got to make sure you pick the right form. So we go back to our fraction key, and we say we want the form like number 2. We want to have a number next to it, and then a numerator and a denominator. So it'll leave the 10 alone. If you pick the first option, it'll put the 10 up top, and you'll have problems. So we have 10 and 1/3, and now we hit enter, and we get 7, which is exactly correct. And in fact, we can really quick check the other one. We can copy this, and it's actually easier than I thought. You just come in here and you change the x value. So now if our x value is 5, we expect y to be 2. So we can come in and just change this out for 5. And let's see if we get a 2. We do get a 2. So we can say this is most certainly correct, and you can move on to the next question with a larger degree of confidence. If you have any questions about this, let me know in the comments below. Subscribe. We'll catch you in the next problem.